So let's start. So as you can see, the topic title of my talk is machine learning project from the start. I'll be talking about the things we can see on the real project. So I hope it will be interesting for you. I will go through ML project organization. Then I will discuss little, and I will show you also demo how to use tool which is named Cookiecutter. It allows you to create a machine learning project from template. And then we will go through MLOps only briefly because it's very broad discipline. And I will discuss and show you demo with machine learning framework which is called MLflow, and it's officially supported framework from Databricks. So here, few of the machine learning frameworks listed from big cloud providers like Microsoft, and there's Azure ML, Amazon SageMaker, from Google also, and Databricks. I highlight the Databricks because I will show you demo with MLflow, and I will show you central part of the MLflow, which is MLflow tracking, which helps you a lot. So you can train your model with tracking all important details about the training, validation, and test. So you can build your machine learning models with higher confidence. Oh, I changed the slide accidentally. But yeah, I finished this slide already, so it's fine. Maybe last thing here, that all these frameworks and tools provides you functionality that you can create machine learning pipelines with this tracking feature. So this is very important to train the model and track all the details you need to know. So here, ML project organization. We all know why it's very important to have organized project, well-organized project, so everybody can quickly navigate through the project structure. So we have it organized in folders. If I'm machine learning developer, I need to, or I know where to look when I want to search for the data. And you can see it has a very standard structure, like you have folder for the test, so you know where to go if you want to write the unit test. And basically this is a Python project with packages. So here you see DevTools package. You can install it into virtual environment, and then you can start to work. Very nice thing about to get this well organized project is that you can start to work immediately. You are going to start a new project, and if you got this, your productivity can be very high, even at the beginning of the project, because you get set up tools which is related, for example, to code versioning. Like you get set up Git with GitHub actions, so you every time you do pull request and you go through the review and you merge to the main, there is a lot of things happening, like the static analyzers analyze your code when it's written in the proper way. Your code needs to pass unit tests, and also whole machine learning pipeline is deployed, for example, remotely on the Azure ML, on the computing cluster, and everything must pass. So this is really something which helps you to develop machine learning driven software or machine learning model with bigger confidence. Okay. So what I prepared for you is a Cookiecutter template for the project. All you need to do is you have to install Cookiecutter, and then with this command you can directly, you can very easily create the project out of the template. And this is something which is very beneficial because we have a project already, and we got this on the real project, and we can start to work right away. You can do it also in the way that you clone Git repository and then you create the project from the template locally from your local copy. Here, how it works: Cookiecutter template. Basically, you have this project structure with root directory for your project, and it uses Jinja templating system framework. What it does, it renders all the things. So it substitutes these variables, for example, here, this project directory with this value. If you are creating this project, it also asks you to provide your own values. This is just default values if you don't provide any other. So in this way, you get a project which is named by your name, directory, and you can imagine you can have a lot of stuff inside the project, and it will be created just for you. And it comes also with the, for example, example for the machine learning code. So you just need to adapt existing example to your needs, and it guides you during the successful end. Yeah. So this is Cookiecutter, and now this broad discipline MLOps can be summarized. MLOps and said very simply about it that the whole MLOps cycle consists of these three main phases. In the first phase, design phase, people who understand business, people who understand the data, sits together, and they identify potential user. They also create a list of tasks which needs to be solved, ML tasks, machine learning tasks, and they also plan for the future development, like they plan, they allocate resources and so on. Then following phase is model development phase. This is the phase where the main goal is to provide the model for production. And here, data engineers prepare whole infrastructure, prepare data, so they are accessible for model machine learning engineers. And machine learning engineers create the pipelines for the training, validation, and test. After they are successful with the development of the machine learning model, they provide it for the deployment to production. And you can imagine this operation phase is about continuous integration and continuous development. And you need to also set up monitors, which says you, or you have to apply monitors on the whole software system you are developing. And in machine learning, you especially need to monitor for the distribution of the incoming data, because once you train a model on some distribution, and then in production, if the distribution shifts somewhere else, the model can give you wrong predictions because it was trained on the different data than you may observe here during the production. So in the machine learning here, the very important part is monitoring of the data set, of the data. And you apply some threshold values or some metrics which tells you about the distribution, and if it exists, it's you get notified, and you have to take appropriate action to fix the problem. Maybe you have to require for another data, which are much more closer to the data you now get from the production, and you need repeat the whole cycle again, or maybe not whole cycle again in this case of the distribution of shift data, but you need to retrain the model, and you will need to hope that you get the good model which will operate in a real world. Yes, MLflow, machine learning framework from Databricks. The central part is MLflow tracking. This is a beautiful thing because you can train your model with the tracking all necessary or needed details about the training process. For example, you can log metrics which tell you about the model performance. Very important. You log all parameters under which you train the model. Also very important thing. Basically everything you can imagine. It's a code version. It's a configuration file for the environment in which you train the model. Basically all the details you need to have if you want to repeat the experiment again, or you need to make sure that, sometimes you have a model and you need to make sure that you know why you get this model. So this is very important. Well, here MLflow comes with MLflow recipes. It's a module of the MLflow, and previously it was known as the MLflow pipeline. They rename it now to recipes. It provides you template for the machine learning pipelines for the now only for the binary classification and regression tasks. So we need to do quite a lot of adaptation to your problem because these are very simple problems. But anyway, it's very useful because it's standardized, kind of standardized. So it's really worth to have a look how it looks like, how you should do your own, how you should solve your own machine learning problem. So yes, very important thing or very useful thing. And I will show you also an example in a moment. And finally, this is my final slide. Then I will go for the demo. Finally, MLflow allows you also do inference, model inference. You can see, then I will show you also. You have several runs or jobs which you run before within one experiment. You can imagine it like once you train the model with this set of parameters, the second time you change the parameters, you train the model again, and you have everything logged. So you see this model performed this well, this model performed this well, and here, this is the thing that it allows you to search for the runs, and you can, for example, load the model for the specific run. So you provide the run ID, and you load the specific model, or you can go to the model and load it to the version of the model. And you can do it programmatically, for example, in Python here, or you can also use this REST API for MLflow. So now let's go for the demo. Hope for the best. It's better now? Okay, I'm at the end of the presentation, so I hope you heard at least something. And if not, then you can buy me a drink and we can talk. Yeah, and the breakdance, I know. So this is toy example. Basically, I got inspired from the MLflow. The MLflow recipes comes with this example for binary classification. The task is that you want to classify whether wine is red or white. The principle here is that the model predicts the probability that the wine is red. So you can see here the flag. So these wines are white, and here this is the ground truth, the label that this wine is 100% red. And the model, according to features, given the features, should give you answer, but not 0 or 1. It can predict, or it predicts the probability that the wine is red from 0 to 100. And you can have a threshold, and if model predicts value greater than 50, you can say, okay, this wine is red. Otherwise, it's white. So here, this is the list of input features. This is basically this data set. It has 6,500, almost 500 rows. And here you can see, you can create a recipe like this with local configuration. So this is the way how you can quite easily with another configuration, say, don't run locally, but run on the Databricks compute cluster. So here it is how the pipeline looks like. So there is a few steps: ingest step, then split step, which splits your data set into 3 subsets: it's train, validation, and test. Then there is a transform data set, which does, or in this step, all the pre-processings are happening. It can be normalization of data, or basically, or any other transformation you want to before you pass, or you pass the data into model. And here you have transform data, goes into train step. Here you train the model, then you have evaluation step, and finally the edge step. I will show you how it works now. Okay, so here, this is the example how to run steps individually. So for example, you can tell, or you can call this run with ingest, and only ingest step will run again. So now it's running. It should be very fast. Okay. Yeah, now it's done. So you can, so it's already finished this step. And now I am going over this. So I'm not going to run all steps individually. I will rather run it at once. No, evaluate, sorry. This. So now I will run that again, like whole steps in the pipeline. So we see the next step, which is now running as a first, is a split. So it after the data are already ingested, and now train step is running. By the way, train is taking the most time from these steps, so let's wait a second, but it will be quick. So we are fine. And after it is finished, we can see here in MLflow UI the list of runs we did for this experiment. So here you can see several runs. I retrained the model this many times, and now I can have a look at the runs. So now I'm in the inference step. I will come back to the running of a training pipeline, but before, let me show you how it looks. So these are my runs. I search for runs here, calling this function. I choose correct experiment, and I see the list of our runs. Here I can see I list the runs, like the very first run on index 0 has the smallest F1 score value. So it's the worst, or this one is worst performing model. Now I can do very simple stuff. I can search for rounds such that I will sort them out according to the F1 score. So it's here. So now this round with this ID has the best performance with this value of F1 score. This one I will probably want to deploy or use for production. Now what I do in this simple example, I just take all the data set, and I do inference, and I evaluate the F1 score. So this way you have a bunch of rounds. You can retrain your model several times. Then you have access to these rounds. You can iterate over them. You can choose the round which suits you most, and you can provide it for production. Okay, so this was this. Now I want to show you another feature of the pipelines, and it is that you see I came back to the previous notebook. Well, it's some error. Never mind. So here I execute this run before, right? Then I went to this to show you inference. Now let's say I want to retrain the model again. So I run the pipeline again, and you see that there is no step running. just right now. So all the steps are skipping because there is no changes. So it is a pipeline I wanted to execute. And this pipeline you can see as individual steps in a sequence. And output of the previous step is input to the next step, right? And if there is nothing new, there is no need to do run of these steps. So there must be at least something new. For example, you can change something in the source code. This is something new, and the make utility recognize it. It's new. You who has some experience with the C++ languages, you know how it works. Make utility. So you create the make files, and then you can compile whole project or build whole project, and only those steps will be executed where what is needed. If there is some ingredient into the recipe folder, then the output, right? It's not necessary to do anything, right? If the ingredient is newer than the output of this step, it is necessary to run it again because you can expect different results. So this is also the feature. So now I force it to run it again from the split because I ingested data manually. Now I can, for example, show you how it works. I can change here the training source code. I can do not very useful thing, but I edited this file, so it's newer. And if I now run it again, I will see these steps are skipped because there is no changes, and the train step works again, and all consecutive steps are executed again. So yeah, this is quite a useful thing because some operations can be very time costly, and this way you can save your time if you run only what is necessary to run. Yeah. And this comes with MLflow recipe. So all you need to do is really to copy the example and do adjustment according to your needs. Sometimes it can be quite difficult, but yeah, it's our job. So yeah, it was all